Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm with Jaap Groot, CEO of Ignion. Welcome.
Thank you, Pat, and good morning to you.
So we've been following Ignion for many years and your unique antenna technology, the virtual antenna. How exactly does that work, and what advantages does it have compared to traditional antenna designs?
Yeah, it's good that you ask, because virtual antennas are a bit different than typical antennas. I think the most relevant difference between, let's say, our products and virtual antennas and what you can find in the market is that the virtual antenna is not resonating. So meaning it doesn't transmit or receive radio waves by itself. It actually is better called a booster. Meaning that we boost the signals that are received or transmitted by the ground plane. And the main reason for doing so is that the ground plane is typically the biggest piece of metal in any IoT device. So by using that physical structure of a device, you are basically better able to create better performance given the metal structure. And of course, in order to make that happen, as product is non-resonant, we need something in between the PCB and our antenna booster, which is called the matching network. And that's where also the magic basically sits, because we can tune it to any frequency. And by doing so, we have several, let's say, flexibilities that you will not get with any other antenna, because they're typically pre-tuned for a certain frequency band or multiple frequency bands, which makes the product very versatile. Whether you talk about existing LoRa or cellular bands, but also when new stuff comes up, ultra wideband being quite in the mode today. Or when people invent 5G or Wi-Fi 6E, we don't need to choose to change our product portfolio. So that is good from our perspective, but also from a market perspective, because people can work with the same components that they were used to before and just adapt it to their needs by changing a few components in the matching network.
Yeah, and I've seen them too. They're very small, so the footprint is minimal.
Yeah, that is. I mean, chip antennas in general are relatively small, right? So if you compare that to what we know before, you and I are from the age where we had Nokia phones with an external antenna. That is long gone. But at the end of the day, for example, FPC's antennas tend to be relatively big, so you need to squeeze them into your product. And chip antennas are by far the smallest products that you can find on the market. And due to the intrinsic, let's say, specifications of our product, our antennas or our boosters are the smallest in the market. But at the end of the day, being so small or being even smaller is less relevant when you talk about the chip antenna category.
So you recently announced the Antenna Intelligence Cloud, bringing the power of AWS cloud computing and artificial intelligence to the antenna domain. Can you tell us about how that works and why it's good for developers?
Yes. So typically when people start thinking about antennas, it's a little bit late in the product design. Meaning that the electronic engineers who design the products basically put the UFL connector and then push the antenna to the end of the equation. The problem being that at that point in the design cycle, you cannot change a lot of things anymore because you are wanting to go to market and you don't want to expand that. So overall, our mission is to make sure and clear that it's better to consider the antenna right from the get-go into your design. Now, if you want to do that, then obviously you need to be able to simulate quite a bit in terms of how that antenna will perform. And in order to enable that, we have been doing thousands of designs like that for customers. And what we learned is that all of them get the concept quite well, but don't have all the tools to make sure that the antenna performs well. which is down to all kinds of pieces of software and understanding and know-how. So by looking at it internally, we thought, why don't we put all that know-how and the tools into a cloud environment so that it becomes more accessible for the market, for the design makers, and also can we speed it up? Because there is a dependency of RF engineers or engineers in general to the providers, to the suppliers. And that dependency is a bit painful because many of the IoT designs, due to its long tail, are initially low volume. So from a market perspective, you might have a brilliant idea, but if no supplier wants to support you because your volume is only 10,000 pieces, then you end up in a nightmare scenario that you just have to pick and choose from DigiKey or Mauser, different types of antennas, and trial and error. And that's not the right way forward. So what we technically did is put all that design power into a cloud environment with AWS and basically put a front end on it, which is called a form, right? People put their requirements in, and then the cloud starts doing its magic and outputs a full report which shows you how to design your device, where to put the antenna, what kind of matching network topology, which components, and how to build your product. And by doing so, I can tell you, it's about a month ago now that we launched it. The number of designs has gone up dramatically because there is an appetite and a need in the market.
Wow, that is great. It really eases the design of antennas for any application. So how is the platform using AI and machine learning in the simulation process, and what benefits does that have?
Well, you can imagine that if we talk about, let's say, thousands of designs, that people who are building, let's say, tracking applications, they all have some common needs. First of all, the thing needs to communicate, and plenty of people take, let's say, NB-IoT or LTE-M in a cellular module as their communications gateway. Then they embed GNSS with a certain GPS or the GNSS type of chipset. So that's a second radio. And often they also do BLE for local provisioning. So now you have a relatively complex environment from an RF perspective. But if you put thousands of designs into the same model, then all of a sudden, the differentiation is not on that physical design of the antenna or how the PCB is built. The differentiation is much higher in the value stack, meaning application layer, what kind of software you put on the device. So the machine learning and AI is basically driving to make sure that we can guide people into somewhat the same direction. Don't make the common mistakes. And to give you a very simple example, everybody puts the casing together with metal screws. If that metal screw is too close to the antenna component, then it will fail. But you can even, let's say, learn from the fact whether it's 2 millimeters away, 3 millimeters away, 4 millimeters away. So the cloud does not just tell you, okay, in your design, that distance is 4 millimeters. It also gives guidance that if you could increase the distance by 2 millimeters, your performance will go up like 10 points.
Wow, that sounds pretty powerful then. So why is it important to the makers in the IoT industry as a whole to have this tool?
I believe that overall RF is still too difficult for many people. There is quite a small group of people around the world who understand this in full detail, and they do mostly custom designs, whether they sit on the supply side for antenna makers or whether they sit in bigger companies who have their own RF departments. So that community is limited, and we believe that by giving people building blocks like Lego blocks to build their devices, supported by powerful tools, of course, we can make it just much more easy for people to use relatively complex stuff. And we've seen that in the software world, where you buy or you can get open source or purchase building blocks just like that. the same thing is basically happening in the hardware world. Cellular modules being an example, right? They're all standardized around the same type of chipsets, but the modules are all quite different. In the antenna world, the same thing will happen. I predict that our cloud will not be the only one, and honestly, NXP has one for their designs, ARM has one for their designs. So it's just making the technology accessible, and in the meantime, predictable, so eliminate risks, that you don't make mistakes from the get-go. And at the end, it results in faster design cycles, and time to market as well as cost are directly impacted.
Well, it sounds like a really powerful platform, and good luck with it. Thanks, Jaap, for talking with me today about the unique antenna platform that you have developed at Ignion, and I think it's going to be a big hit in the IoT industry. To our listeners, you can find more videos at videos.microwavejournal.com. Thanks for watching today, and remember that frequency matters.